Alright, welcome back grade 12s, and let's take a look at section 1.4 today, looking at inverse functions. So the graph of an inverse function is a reflection of whatever function you're working with in the line y equals x. Now the line y equals x is created when the y coordinate and the x coordinate are the same. So it passes through 1, 1, and 2, 2, and 3, 3, etc. It's a diagonal line. Any coordinates x, y of some function f of x will map to y comma x. So we find the inverse of a graph by switching the coordinates. If we've got some point like, what would that be, 3, 0, over on the right there, the blue one, then the inverse of that is going to go to 0, 3. So f negative 1 of x, the one you just saw, that's the symbol for inverse of f of x. So f with a little negative 1 as a superscript. It's almost like an exponent, but it's not. That's the symbol for the inverse of a function. So here we're asked to determine the graph of an inverse. So we've got that purple graph, and really all that we're doing is taking the coordinates like 2, negative 1 and switching them. 3, 0 and switching them. 6, 1 and switching them. So that part's easy. Let's look at determining the inverse of a function algebraically. Now I mentioned in class that you start by swapping the x and y coordinates. After that, all you do is solve for y. So we subtract 5 from both sides, and then we'll divide both sides by negative 2 or multiply by negative 1/2. Sure, or negative x minus 5 over 2. All of those mean the same thing, those last three, the red and the purple. To graph it, and here's a third version of it, to graph it I could graph negative 2x plus 5. And you can pause this video and back it up just to see if you, because it is going a little fast, and you can back up and see where things are. I changed the volume there, hopefully that's a little better. And when you graph the red one, which was our first equation, number 1, and the green, which is our second equation, number 2, and then if we plug in y equals x, you can see that the left side, or above that, is a reflection of what's below it. Okay, they match. Those circled points and the square points are inverses of each other. Their coordinates are swapped. The domain and range of the function are equivalent to the range and domain of the image. So if the domain is, all real values of x, then the range is going to be, we're going to switch those x and y coordinates. So the range is going to be all real values of y. So we've got x squared minus 4x plus 2. We're asked to express it in the form x minus h squared plus k, so we can see the translations. And then we're going to determine the inverse of that form, and then we're going to graph both. At the end, we're going to restrict the domain of the original function of f of x so that its inverse is also a function. So first step I did here is I completed the square. And again, if you're new to these videos, remember you can pause them anytime. You can rewind them, and you can see what's going on. Of course, you'll have to listen to me again, though. So solving for y there in purple, getting y by itself, and we've got 2 plus or minus the square root of x plus 2. Now I know how to graph the green part, x minus 2 squared plus 2, or minus 2. So I've got my vertex at 2, negative 2. I draw my regular parabola. And I'm going to use those points, each of those dots that I've drawn, to find the inverse of the function. You may not have learned yet how to graph a radical function. We'll learn that soon in chapter 2, matter of fact. But I can still graph the inverse without knowing anything about the equation. All I have to do is switch coordinates, swap x for y, and plot the new points, which I've got in purple. I always try to draw in that line y equals x, so I can see that the one side is a mirror of the other. Now I'm restricting the domain on the original function in green, and then my inverse was that purple part that I highlighted. Okay, so back that up again, take a look at that, and I restricted the domain to x is greater than or equal to 2, which restricted the range then of the inverse function to y is greater than or equal to 2. Hope that helps, and we'll see you in class on Monday. Bye bye.